and our editor legal Srivara sir to the function. And Professor Savita Ravindra ma'am. Studio Physics. Dr. Shalini Pradeep ma'am. Associate Dean IMS. Now I request you all to rise for the Ramaiah anthem. I request all the dignitaries to officially inaugurate the program by watering the plant.
Very innovative ways of
Exactly.
No. Yeah, that's you.
It will grow more and more and more.
The plant of research may become the tree of research.
Thank you all. I now request the dignitaries to take their seats off the dais.
It's okay.
I'll be there.
Okay.
I now request our Principal and Dean, Dr. Shalini Nui ma'am, to give the welcome address.
Wishing you all a very pleasant morning. I deem it a privilege to be here today to welcome you all. I feel it has been the work and the support and encouragement of all our previous deans and faculty which has culminated in this day. Not to forget the support of our existing faculty who are in the medical college. We thank you all for participating and supporting the Division of Research and Patents so that we are able to celebrate Research Week this year. I would like to give a brief account of the research ecosystem in the college. We have the Division of Research and Patents, which is sort of central to all our research activities in the campus, which is supported by various other research organizations like the Rich Tech, like RICFI, Ramaiah International Center for Public and Health Innovations, and other organizations which are supporting research activities within the campus. I thank Dr. Nandakumar, heading the Division of Research and Patents, for bringing this to a wonderful celebration culmination, which he is ably supported by Dr. Tanuja, Dr. Akshay, Dr. Vidya, Dr. Radhe, and the other two members are Preeti Parna and Monica. So thank you all. Just before we go into the context, I would like to speak a few words about Dr. N.S. Murthy, Nandagudi Srinivas Murthy. He was here with us for many years, and I consider it, my good fortune to have been associated with him. And I think many of the faculty, many of the students who have been here during those years would also say the same thing. He has been, supporting research activities throughout the campus, not only in Ramaiah Medical College. He supported other institutions also. And I would say it was a selfless interest. He just wanted to see that all of us, were interested in research. He wanted to ignite the spark of research in each and every one of us, whether we are faculty or students. And therefore, we remember him very fondly and gratefully. And I would also wish to welcome his family members who are here with us today. Mr. Madhu and his granddaughter. Thank you all for coming and being with us on this special occasion. A few words about what we are, focusing on today is public health. The coronavirus pandemic has actually made healthcare workers as well as the people in various continents realize how important it is to have public health surveillance and public health measures to control diseases. It is really important that we monitor the health of the public, we support and strengthen the health of the public, and this can only be done through public health measures. Public health improves the quality of life, not merely the duration of life. Public health, brings in prevention of diseases rather than curing diseases, which actually preempts the social and the economic burden on the family. Prevention, therefore, is only possible if we create awareness, and this is what public health also stresses upon. Another important factor about public health is that it makes the voices of the unheard heard. And therefore, I think all of us have realized how important public health is during the last 2 years. I'm thankful now to Dr. Soumitra Das, who has worked during the COVID pandemic and even now. He's the director of INSACOG, Indian Surveillance for SARS-CoV Genomics. So we welcome you, sir. And he's the professor of microbiology and cell biology in the Indian Institute of Science. And he is also the recipient of the National Bioscience Award from the Department of Biotechnology. Welcome. Giving us the first Dr. N.S. Murthy oration. I'm very grateful to our Vice Chancellor, Dr. K.K. Raina, who's a distinguished professor, also served as the Vice Chancellor in DIT in Dehradun before joining us as Vice Chancellor in Ramaiah University of Applied Sciences. We welcome you. I'm very grateful to our Chief Executive, Dr. N. Srinivas Murthy, for having graced the occasion. He has been in, top level positions in the government as an IAS officer, and he was very happy to be here today when we told him that it was Dr. N.S. Murthy oration. Thank you and welcome, sir. I also thank our Chief Financial Officer, Dr. Venugopal Shastri, and Mr. Shrivara, our HR head and legal, taking time to come here. And I thank all our faculty members and students for coming here, making time to come here despite your hospital activities. Thank you and welcome everybody.
Thank you, ma'am. I now call upon our VC, Dr. K.K. Raina, sir, to share his words of wisdom.
Namaskar and very good morning to all guests and esteemed speakers and family of Dr. Murthy being present here on this special occasion. On the dais with me, our Chief Executive of the Gokula Educational Foundation Medical, Shri Srinivas Murthy, Dr. Soumitra Das, a distinguished professor with great capabilities. I think we have chosen the best person to go for the citations of Dr. Murthy, Dean of Ramaiah Medical College and the Principal of RMC, Dr. Shalini Nui, a good friend and colleague, Dr. Nandakumar. We have all distinguished persons here, and when we don't have people like finance officer, I think the career's presence in research is very, very important. Mr. Shastriji, Mr. Srivara, HR plays a very, very significant role in there too, and Dr. Sarita. To do research, you also need some physical therapy at times. We shall be seeking your help and support from time to time. And it indeed a great pleasure. Today is a special day with many facets. I'm sure you all know young students and very beloved students that today we are celebrating the World Students' Day. It's a great occasion. And it is also the birthday of one of the illustrious sons of India, Dr. APJ Kalam, which we celebrate throughout the nation as the Innovation Day, the Creativity Day. And when the Ramaiah Medical College and the research wing is also celebrating 3 days of this comprehensive research week to commemorate with the founders, Dr. M.S. Ramaiah's birth centenary, I think it has more applauses to think of and a lot more vibration that we create out of all these great things. Ramaiah University of Applied Sciences, you know by now, is truly a multidisciplinary institution. And with numerous specialization, you will find it here. Whether it is health sciences, engineering sciences, we talk of sciences, the legal aspects of everything that we have it here. So it gives us a great privilege on this campus as its family members to celebrate all creativity that has happened over the years. But I think we should not be happy with that only. We should also look for the futuristic approaches of creating new knowledge, creating newer technologies and harnessing them for the sustainability as well as for the betterment of the human generations and how we can save the planet. Dr. Shalini and the team, I personally thank you for the kind invitation and making it possible. At RUAS, we are also planning today to have an exhibition of nearly 193 projects. Dr. Shalini knows about it and all team members. Over the years, over the last 1.5 years or so, our graduate students have done wonderful projects. Today, we wanted to also exhibit it, but because of the coincidence of events, we thought we should postpone that event. And on 12th of November, we are going to celebrate the startup day at Ramaiah Technology Campus in Penia, which is in the Ramaiah University of Applied Sciences. Our idea is to invite all students from our own group institutions, as well as the children from various schools. We will also come to know that what kind of thought process is being sown, the seeds of success are sown, and how our students are looking at the contemporarization of the knowledge, at the same time, taking it forward for the betterment of the society. I wish you will also find some time to be a part of that event. Friends, research is searching something new. You know, I was a research scholar many years back before I came into the teaching profession. And my father asked me, we used a craze. We had no laptops. We had no, mobile phones. We used to carry the notebooks. So I wrote in my notebook, Kuldeep Raina, research scholar. So my father, very knowledgeable person, a scholar of Sanskrit, and they said, what does it mean? I said, I'm a research scholar. He said, what are you doing? I said, I will do PhD, I will do this. He said, but I don't want to know what is research. Oh my God, he took me back many years. And since then, I always remember when it comes to research. He said, you are not doing anything new. You are searching something where there has been a great knowledge, whether it was from the sages or whether it was someone else. Just go on search and go deeper into it. And I think that is precisely when we think research, it is searching something, searching our soul, searching our thought process, and looking at what knowledge has been created by the humanity over the years. And what were the gaps? And from those gaps, we take the extracts, the trends, let me take it just now, let me do. So that's where we try to explore the new knowledge, which becomes a new research for other people. And we get the degrees like doctorate. We also get our papers published on that. So it's a phenomenon which is never ending because creativity never ceases. I think there is some atom, some molecule which tempts us to look at those aspects. Some of my research work is also related to the nanotechnology, the nanosciences which I did. But when I was going through the research profiles of the people, I think it was not new. One of the greatest scientists of our nation, Dr. C.N.R. Rao, whom I'm sure that Dr. Shumatada must be knowing very well, he is the man who brought nanoscience in a practical aspect of our country. The Bharat Ratna, truly, he deserved it. And I had an occasion to meet him thrice in my lifetime, once in IASC, and once we were in the British Council in Delhi, and once in Vikrambhavan in Delhi. So I think the man had great vibration and nano mission programs, which was headed sometimes by my very good friend, Dr. Ajay Sood and others, they brought it. So what were the extracts? But when I look at the literature, this nanoscience was not created in the year 2000 or 2020 or 2021 or so. No, I think since 4th century, our sages were using the Bhasma as a medium for curing the patients. That time, the pharmacy, which has taken a different shape now, has been known to the Indian scientists, Indian thought process, thought people. So therefore, if I look at research that way, I did nothing new today because it was done thousands and thousands of years of back. So when we think of having such audience and also the people who matter a lot in looking at the research through a different prism, I always try to express myself in saying that we as researchers, we as faculty, in whatever capacity we may be, are also the learners. So together, at Ramaiah University of Applied Sciences, I am confident, I am sure about it, that in due course of time, there is going to be a research thought process that will have a multidisciplinary approach in the problem solving and create newer problems for future generations to see that how we can make this society sustain with the idea, with the research that is going to be produced by us in India. Many of the research labs in US, even in Korea, and some of them in China too, it is not getting reflected many times, is also driven by the Indian thought process. We go there, do our doctorate, do our postdoctorate, come back. So this transport of knowledge from one continent to another, one country to another, is also going to stabilize newer ideas in our young minds. We at Ramaiah University of Applied Sciences are very hopeful that very soon, with this collaboration, we shall have a strong database for our research works. And we are also looking at it, creating a new verticals with the futuristic approach, where it will be known that this idea was nucleated not at MIT, Massachusetts, not in Harvard, but it culminated from the thought process of the brilliant minds who work at Ramaiah University of Applied Sciences. I'm sure the day is not far away. I thank Dr. Murthy's kindly to be here with us today to bless us. A special occasion, I think we dedicate it to your presence here. With these words, thank you very much. May God bless. I'm sure the last 2 days, 13th and 14th, must have been very, very vibrant, scintillating. And when we conclude, there are going to be many takeaways from this 3-day research orientation programs. Dr. Nandakumar, wherever we can think we can be of some help in strengthening further, we are always there to support you. We should not look only local. Our thought process should be undoubtedly local, but with global, there are a million ways, not only one. Jai Hind, Jai Karnataka. Thank you.
I now call upon our CE, Mr. Srinivas Murthy, sir, to encourage our young researchers.
Good morning to all of you. Dr. Soumitra Das, Dr. Reina, and all the colleagues present here. Actually, I had requested Dr. Shalini Nui to excuse me today, but then when she mentioned this is an event in honor of Dr. N.S. Murthy, I said I would certainly come. Of course, there's no way I could say I could be absent on an occasion like this. You have heard Dr. Reina explaining his view about the importance of doing research in an academic institution like this. As our motto says, Gnanam Vijnanam cha Bhakti Sahitam. He has given you the Gnanam aspect of it. Vijnanam, I think Dr. Soumitra Das will give you about genomics. I will only try and take care of the Bhakti part of it. And showing our respects to Dr. N.S. Murthy's memory, because his contribution to this institution and its pursuit of research has been phenomenal for many years. And as the old saying goes, Vidya Dadati Vinayam, knowledge always makes people very, very reserved and humble. And he was such a simple person. And whenever I noticed his presence in a group, I had to ask somebody, who is this person? This is Murthy. And he's a great support. He's a big pillar of support for all our research scholars, young and old. And his contribution, though it is never mentioned in the papers, I think mostly the principal investigator or somebody else, the papers get published in their name. But the contribution that Dr. Murthy made in making those papers cogent and meaningful for everybody to, appreciate, was known only to us, the colleagues who worked with him. A great soul, and till the last day, he was associated with our institution. And It's unfortunate that now we could see him through the COVID period. And our institution is poorer by his absence. And we are grateful to the family for continuing your affectionate association with our institution and having come here on this occasion. Dr. Raina also mentioned Dr. Kalam's name, another great man who was equally humble in his appearance. I had occasion to meet Dr. Kalam several times. First time when I was working in the Indian Space Research Organization, later on in many other official capacities. I have never found him acting like a great scientist or a great intellectual. Even when he was president of India, we had invited him for a function in Gulbarga. He came, one of my department's functions, launching a new program for government of Karnataka for the rural masses. He came and he stood on the podium to make the speech, and he found 50,000 people assembled in that crowd in the what is now the airport of Gulbarga. And he said, if I speak in my language, English or Tamil, they won't be able to follow. So I need your help to come and translate my speech. So I stood side by side with Dr. Kalam. Each sentence that he uttered, addressing this audience, I had the privilege of translating it to Kannada. And we spent a good part of an hour, expounding Dr. Kalam's philosophy of how even rural areas should be developed on par with the urban areas. We used to have a concept called Pura. That Pura meant that, the urban kind of infrastructure should be developed in the rural areas also. So it is an occasion for us to remember these two great souls, Dr. N.S. Murthy and Dr. Kalam, each unique in his own way, and each having rendered valuable services, one at the level of our institution and the state, another at the level of the country. We need to remember these people just for the sake of inspiration. Dr. Murthy never came around saying that, how much are you paying? How much will you pay me next year? No. And I always felt embarrassed looking at his, remuneration figure or whatever that we were paying him. Is it possible? This person is working only for the love of his profession. He had earned knowledge and he had to give it to the society. There are many people who sometimes come and represent, okay, I should be promoted or I should get more salary or more allowance or more whatever. I need a car or something else. There was one great person who embarrassed me by the humility, by not making a demand from the organization, except to devote themselves to this pursuit of research. And I think, examples like this should inspire all of us, young and old, to have that element of dedication. It's not enough if you have knowledge and wisdom. You must also have that element of dedication. That probably is what relates to Gnanam, Vijnanam, cha Bhakti cycle. Because ultimately, the human endeavor achieves fulfillment only when it blooms and gives back to society. Not merely when it accumulates knowledge, but when it shares it with the society. So that is the whole philosophy of Dr. N.S. Murthy and Dr. Kalam, which we need to do on this occasion. I hope this will inspire the oration today by Dr. Soumitra Das, will make many people to pursue research not only in the field of genomics, but many other areas which are very, very important and relevant to mankind. Thank you very much for this.
Thank you very much, sir. The DRT has compiled the annual report of 2021-2022 in the form of a souvenir. I now request our Honorable C. Sir to release the souvenir.
And vice chancellor, because we have two of these things. Yeah. I would request Dr. Das and vice chancellor to take. Yeah. Yeah, this is one for you. So. Is it the same? The same, sir.
Thank you all. I now request our VC Dr. K. Raina sir to distribute the faculty research awards. The first prize goes to Dr. Chitra from I think Chitra ma'am is in the OPD, but then we have Dr. Nihar Patil.
I hope envelope has big cash amount.
Dr. Jyoti GS. From the Department of Obstetrics and Gynecology. Dr. Lalita from the Department of Community Medicine. Dr. Mahindra from the Department of Neurology. Dr. Sunil Cortado from the Department of Neurosurgery. Ms. Veena Kiran Nambiar from the Department of Physiotherapy. Thank you, sir, and very congratulations to all our winners. I now request the dignitaries to take their seats off the dais.
Okay, Rama.
I now call upon our sixth-term student Parth Mathur to share his experiences of the ICMR STS project.
Respected teachers, faculty, seniors, and dear friends, a very good morning to all. My name is Parth Mathur. I am a student currently in third year MBBS as MS Ramaiah Medical College. I am privileged to be here to share my experiences of undertaking research work at Ramaiah Medical College and hope some others in their pursuit of science. Research is to see what everybody else has seen and to think that nobody else has thought. Ramaiah has a very robust medical research environment, and there are ongoing research projects on a variety of topics being undertaken in every department at all times. These research studies involve undergraduate students, postgraduates, interns, consultants, and others. So basically, there are ample opportunities for anyone who is interested in going an extra mile to explore, learn, and innovate. The main purposes of research are to inform action, gather evidence for theories, and contribute to developing knowledge in a field of study. Research is very important to build scientific development and stay up to date with all recent advances and in the respective fields. It helps build critical thinking and stimulates one to dig deeper and find solutions. Various study designs help to acquire knowledge, answer research questions, or undertake problem solving, making the results relevant for its use and practice. And very fortunately for us, our Division of Research and Patents in the Institute plays a very active role in ensuring that the student researchers get the best of guidance and training. Scientific research plays a fundamental role in current medical practice, and it is of great importance that medical students relate from it from the beginning of their professional careers, since it generates multiple benefits that will be reflected during the course of their careers as university students and future professionals. However, getting involved in research during the undergraduate days is not always easy, as students have enormous burden of studies besides other obstacles and challenges that result in a reduced number of research students. However, by adopting appropriate strategies, one can work towards research, which in turn helps in the development of essential skills, critical thinking, and will facilitate responsible clinical practice. Before college, I had a very limited exposure to research, as mostly it was limited to small school projects. However, on joining the college, we were taught about the importance of medical research and exposed to the research environment in Ramaiah during our foundation course itself. This prompted us to start thinking as to how, as undergraduates, we should make the best use of this opportunity. During the lectures, from time to time, the professors kept us updated on the latest research being undertaken in Ramaiah and also exposed us to the latest from across the globe. We were introduced to the short-term studentship STS program by the Indian Council of Medical Research, ICMR. I realized that this was a great opportunity and initiative started way back in 1979 with the purpose to encourage undergraduate medical research. This allows undergraduate medical researchers to carry out a project during the summer months. The program offers a flexibility to choose any topic that interests the student and to work under a guide and in the medical college. This is one of the only initiatives in India that is customized for the undergraduate students. The research has to be completed within 2 months and submitted online to ICMR. I applied with my proposal during the first year in college but unfortunately, it did not get accepted. Mistakes and failures are part of the learning process, and the rejection did not hold me back. There are a total of 1,200 medical and 300 BDS spots throughout all medical and dental colleges each year for the SDS program. And during the end of second year, I started planning to apply again. There were a total of nearly 10,000 applications this year, and my proposal got accepted. It felt like a battle won. My project is a study to assess the willingness, the perception, and awareness of healthcare workers involved in providing medical care to patients via telemedicine and the promoters and barriers that exist currently. Telemedicine is a topic of great relevance today. In the wake of COVID-19 pandemic, remote healthcare access should be part of routine health delivery and universal healthcare. Studying the hub and spoke model followed in Ramaiah with its peripheries like the Avati, Leena, and Kaivara centers. I found that there are certain barriers like technological limitations, lack of high-speed internet in some areas, workflow integration, and initial user hesitancy that, if removed, would make the whole system much more efficient. I am now at the stage of finalizing my report and will be submitting it very shortly. My learnings are enormous. From choosing the research question, the type of study and methodology, doing a review of literature, working on a plan of analysis, developing informed consent form to get ethical clearance, I received the best of guidance. Being in third year, I was taught how to apply all the theory knowledge that I was learning in real world scenarios and how to tackle problems on the way. I got hands-on experience on data collection, data analysis, using the statistical tools, and report preparation. I understood the importance of adhering to the ethical principles and the values that come with them to promote mutual respect and fairness during the study. In addition, I was provided with many opportunities to present my work in front of other colleges and dignitaries that collaborate with Ramaiah on various projects. Ramaiah actively involves students in innovation-related activities and working together with other medical as well as engineering colleges, strengthening our networking skills and aiming for breakthrough findings and patents. Students get access to state-of-the-art laboratories and technology like 3D printing that they can make use of. There are numerous projects running in prestigious institutes like the Indian Institute of Science, NIMHANS, ICMR, and other foreign universities like the University of Illinois Chicago and Groningen that Ramaiah encourages its students to be a part of. Such involvement of undergraduate medical students in research will facilitate evidence-based clinical practice among the future doctors and help to generate interest in developing cutting-edge innovation and help to generate and for the benefit of the society. The division of research and patents made my first experience into the world of medical research very holistic and has encouraged me to sail further, do many more research projects, and become a good doctor. With these few words, I hope I was able to provide an insight into my fascinating entry into the world of medical research. Thank you. Especially thank the DRP, my guide, Dr. Nandakumar, and all the faculty that helped me through the way and kept encouraging me and providing me meaningful opinions. Thank you.
Thank you very much, sir, for sharing your experiences. I now call upon Shalini Nui ma'am to give a small token of appreciation to her. We have with us Dr. Chitra. I would like to request Dr. K.K. Raina sir to award the award Dr. Chitra.
So Dr. Chitra came running from OPD to receive, I am sure there is going to be plenty in this envelope.
Thank you, sir. Thank you, ma'am. I now request Dr. Yashaswini, postgraduate, to share her experiences on population health research insights.
Good morning all. I would like to thank the dignitaries, Department of Community Medicine and Department of Research and Patents for giving me this great opportunity to be here today and be part of this program. I am Dr. Yashaswini, final year postgraduate, Department of Community Medicine. I want to say that I am an in-service candidate associated with ESI Karnataka for 9 years. I have completed my undergraduation in 2010. So with this, I want to go tell about myself because my knowledge about research was very minimal in my undergraduation days. Could be because not much emphasis was given to research those days. Compared to the present days undergraduates of Ramaiah, I see that they are very actively participating in research and beyond it. So thus my journey to research began only in post-graduation 2 years ago. That is with my thesis work on occupational health. At this point, I would like to thank my guide, Dr. Dinesh Rajaram sir, an associate professor, my co-guide, Dr. Priyadashini ma'am, assistant professor, and Mr. N.S. Shivraj sir, associate professor, biostatistics, for guiding me. Initially, it was not easy for me to understand what research was. So my knowledge about research has been expanded in this 2 years in this college. So by attending many departmental project works, seminars and journals that happen every week in our department. At this point, I would like to thank Dr. Lalita ma'am, our HOD, and the whole Department of Community Medicine and my co-PGs for guiding me through what research is. So my knowledge was not completed with this. I had to attend many more. It included attending some guest lectures. Some of the guest lectures by our DRP department, like topics on research methodology, manuscript writing, and understanding JMP software, which is very much required for analysis of any research. At this point, on this occasion, I'll take this as an opportunity to thank Dr. Nandakumar sir and the whole DRP team for enriching our knowledge on research. I have also attended online classes on basic course on biomedical research, which has given a complete knowledge what research is. I've attended many webinars on research. I've also attended many conferences like CatchCon 2020, IPSM-Con, and Association of Occupational Health Karnataka, and many more. So as a public health person, we know that theoretical knowledge is very different from what happens practicality when we enter the field. So thus, very importantly, my practical knowledge on research was gained through some of the field activities. It could be some ICMR project. This was a pilot study done on non-communicable diseases, some WHO projects on National Public Health Surveillance Project. This was, I participated as an external monitor for Pulse Polio Surveillance Program. Also as supervisor for Intensified Mission Indradhanush to know the immunization status of children below 2 years. And also for COVID-19 vaccination monitoring at session site and house-to-house survey. as a postgraduate in public health, I would like to say that I understand research as a process of systematic collection, description, analysis, and interpretation of data that can be used to improve the health of individuals or the groups. Population health research is an interdisciplinary field, focuses on the factors that influences the health of population group or the whole population. It addresses the health outcomes, health determinants, policies, and interventions. For any research to be successful, we need to get results. But most important is the process in which you get that results. The key attributes of a good results is planning, accuracy in data collection, and an unbiased interpretation. The need of research, while we all know that clinical research addresses an individual patient needs, public health research gives us the epidemiology of health and diseases of the whole population, which includes the frequency of disease, incidence and prevalence, the distribution of disease in terms of time, place, and person. Determinants of health, it could be biological, behavioral, spiritual, or socio-cultural, economical, or ecological. It encourages people to think and view things in terms of cause and effect. My understanding as a public health research PG student, research plays an important role in measuring the magnitude of disease, the disease trends, and the risk factors. It could be the agent factors, host factors, and the environmental factors responsible for the disease causation. To know the incidence and prevalence of disease, to know the pattern of care needed so that we can develop some public health interventions to help to prevent or mitigate the problem, to know the healthcare costs, to implement or deliver solutions through new public health policies and programs. And finally, to build your credibility. With this, I would like to end my talk with a famous quote by Albert Einstein. If we knew what it was we were doing, it would not be called research, would it? These are my references. Thank you.
Thank you, Dr. Yashaswini. I now call upon Dr. Nandakumar sir to give Dr. Yashaswini a small token of our appreciation. We would also like to welcome our Pro Vice Chancellor, Dr. O.P. Karbanda sir, and Dr. J.N. Reddy sir. Dr. J.N. Reddy.
There are more flowers for you. Keep coming, keep. You are not truly untouchable. We're touching you more times now, sir.
I now request Dr. Nandakumar sir to give an overview of research at RMC.
Thanks, Dr. Lata. And it's been an honor, privilege, especially for today, because Sir told, we are commemorating two great personalities in India, one APJ Abdul Kalam sir and Professor N.S. Murthy. Because today, we were choked with emotions for this event, for the reason that, like I was just telling Raina sir, that I have spent more time with N.S. Murthy sir in the last 10 years, more than Madhu, because we were working, and his passion, dedication, and motivation was something which is inexplicable. And yesterday with Purna Chandra, who was part of our Ramaiah community medicine team, when we were talking, we have never felt that sir is not with us. In fact, anything statistics, we say, sir, the PPT is there. So in the sense that like he has made his presence in such a way that it would go for the next whatever millennia that sir's presence is there. And research, this DRP started with the vision of creating a conducive ecosystem because it was meant to be a one-stop solution for research where any student, faculty, or any individual on the campus should not be go searching for any resource that was required for research. That was the whole intent of DRP. And today, thankfully, the top management, the senior professors, the deans, the former management, CFOs, head HR, have encouraged us in any way that we would want that research has got its due diligence and importance. Earlier, it was a necessity, an ancillary, because as Yashaswini mentioned, or the students are mentioning, oh, what is your profession? You are doing this plus research. But today, we don't have a choice. Research is an integral component of whatever we are doing. It would be there and it is going to be there. And as Raina sir told, jignasa, gnatum ichasi iti jignasa, that inquisitiveness is an inherent entity of any learning. So a learner, if they don't have the inquisitiveness to understand it in depth, without research, there is no output or outcome. So in this context, we are happy that like we have over the last 1 decade, it has been exactly a decade, 2012, the DRP was started. There have been stumbling blocks with initial problems, but today we can fairly with some confidence say that the systems, processes and some outputs which has come out in the form of this report. In fact, Pro VC sir, when he first met us in the DRP, asked, "Aapka koi annual report hai?" So within last 1 week, the entire team of DRP, we put together because we had this information for NAC, NIRF, and today, like research gets 33 to 40% of share in any ranking or rating. So the THE ranking, the NAC ranking, the NIRF ranking. So we have the information, but today it should be cohesive. It should be sort of like inter and trans. Sir, like I'm happy to share that 47%, yesterday we did that statistic, 47% of the projects that are there in the book have more than 2 departments. And 13% of them have more than 3 plus an engineering component. Because today research can't be done in silos, not today, but anytime it can't be done in silos. And unless there is an integration of entities to come together to solve that problem, because be it be a human research or any AI ML based research, today everything there is a convergence where health, education, service and the technology convergence that is happening. So we would strive more with our own university coming together, and the Directorate of Research has been empowered to bring together these independent entities who are working in silos onto a common platform. We are all one family, and we will ensure that by the next year, this 43% will become 75 to 80%. Almost all projects will be having more than 2 or 3 departments coming together, and we will ensure that in the next 2 years, 100% of the projects will be done from more than 2 or 3 departments as relevant. Professor Jain Reddy sir also mentioned it yesterday that diversity in research is an inherent requirement. It is not a desirable thing, but it's an inherent requirement. Hopefully, with your blessing and support and encouragement, we'll be doing that. And I wouldn't take much to present the report as such, because we'll be sharing a copy with everyone, both the hard and soft copies. Basically, the report entails the trainings that have been conducted by the Division of Research, and I was happy to get an instant feedback when Yashaswini or Per youngsters say that like the trainings have been useful, it is meaningful. So we have those trainings, but the trainings by itself is not a means to an end, which has resulted in 374 projects which have been scrutinized by our scientific and ethics committees, which have resulted in 543 publications, of which 176 have been in Scopus. and PubMed. So those numbers are what we would try to improvise, where it's not just the quantity of the numbers or the citations of the Q1, Q2s, but the societal impact for whom the research is being done in the first place. So it is not just getting a doctoral degree or a publication in a high impact journal, but it should actually reach the patient or the population health or the public health that we are talking about, that research will have its meaning. So we have put together the publications that have been brought about. We have put together the projects that are underway, and they are all funded projects from ICMR, DST, DBT, the government of Karnataka, and other entities, where all projects are more than 3 departments. That we have ensured that no single department has submitted a project on its own. So there are multiple investigators from not only Ramaiah, but from other collaborators, the Indian Institute of Science, the University of Illinois, for getting these funded projects. And also the diversity within the Ramaiah institution through our sister institutions, Ramaiah Institute of Technology, Ramaiah Arts and Science College, Ramaiah Hotel Management. So all these food technology, they are coming together and working for and in health. The physiotherapy department has a very active involvement in research and engagement, and also with the innovation in terms of patents that are being granted by that. So the entire details of the whole research process and output and outcomes have been there. Probably the next year, Karbanda sir, I promise the impact part is what, with your guidance, we are going to bring. Say that the societal impact, CE sir always mentions, you do everything, but it is the remotest part of the most vulnerable groups to whom this has to reach, has it reached. So we will ensure that the societal impact and the social impact studies will also be taken up with our social sciences college, and will ensure that they are brought out in the form of publications and the white papers that are there. But more importantly, the people should come and they will speak for themselves, that whether the research has translated to the people who are receiving that. So, and I thank my entire DRP team, the management, the senior professors, and the entire set of awardees whose posters have been put up in the atria. And these are the people who have won national and state level awards for the research work that they have done. So it's a very proud moment for us that there are 45 of such posters which have got first and second prizes at the national and state level of more than 250 participants. So congratulations to all, and also the research awardees. And this is just a beginning. The research awardees, I mean, the process was very tough because we had multi-parameter assessment. It was not just the publication or 2 projects or 3 districts. So a holistic approach with graded weighted points was provided with peer review and 3 or 4 committees. So it has more of a process-oriented thing for choosing that, and all the researchers and all the faculty will be receiving this award in the next 2 or 3 years, because we will ensure that everybody has a meaningful research component for them to deliver. So thanks for the opportunity, and we'll have the next one.
Thank you, sir, for taking us through what has been done in Ramaiah so far. We have now come to the much awaited talk of the day, Dr. N.S. Murthy oration. We will now have a small video about Professor Murthy, sir.
Today we have also dedicated a seminar hall in community medicine department in memory of Dr. N.S. Murthy. So we have named the translational seminar hall.
Remembering our beloved mentor, Professor Srinivas, I can't say how emotional this is. He was a person who was so humble. He was a person who came to us clinicians and kept saying us, please do research, please come. If you don't have time, I will come wherever you are. I don't think we can ever meet a person like him. Dr. Murthy had his master's degree in mathematics and statistics from Agra University. He obtained his postgraduate and doctorate degree in epidemiology from the University of Tampere, Finland. He had his postdoctoral training from the School of Public Health, University of Cambridge, UK, and he had been an elected fellow of the Academy of Medical Sciences of India and the fellow of the Indian Society of Medical Statistics and an adjunct professor in epidemiology at the University of Tampere, Finland. Dr. Murthy started his career at the Department of Preventive and Social Medicine at Banaras Hindu University as a faculty. He joined ICMR in 1976 and has served in various capacities in ICMR. He superannuated from his services during the year 2004 from the Institute of Cytology and Preventive Oncology, Indian Council of Medical Research, New Delhi, as Senior Grade Deputy Director Biostatistics and Epidemiology, and later on continued his research and teaching activity as Emeritus Medical Scientist under ICMR. From June 2009 to September 2012, he was Professor and Research Coordinator at Ramaiah Medical College. Subsequently, he rendered his services in our institute as the Research Director. His main area of interest was biostatistics, research methodology, design, execution, analysis of data, and so on and so forth. The amount of knowledge he had, the amount of notes he had an answer for everything for us. If you went to him, he would say, wait, I have it written down somewhere. And he had files he had preserved, which for many years he had preserved those files. And he had everything which we required, and he always had answers. If he didn't understand something, he was very patient to make us sit down and make us understand. He won't let you go unless you understood what the problem you had gone to him for. He was always very humble. It is impossible to believe the amount of knowledge he had, and such a humble person, that it never came across that he knew so much. He had done so much work. Nobody would know the magnanimity of his knowledge unless you actually saw his CV. He never came across as somebody who was pompous or who, he came to everybody and said, come do research. That was the kind of man he was. I don't think we can have another person like him. His unbound enthusiasm for nurturing young researchers and motivating them for publishing is a virtue to be emulated. He always had a positive note for everybody, young and old and new. He never said, you can't do, you can always do. He encouraged the students to take research activities and contribute to science. His down-to-earth nature and simplicity are an inspiration for many of us on this campus. He will be remembered on this campus for encouraging the faculty to undertake many research projects and for applying for various awards and memberships like NAMS. I don't think many clinicians I'm sure many clinicians who got NAMS will know that it's because of Murthy sir that we all got it. He would come find us, ask us, how many publications do you have? Come, fill the form, send it. He made sure that we sent those forms. It was because of him, many people in this campus have this NAMS degree. We're really privileged that we could be with him. And it's really a great honor that we had a chance to learn from him. So today we have dedicated this oration in his name, and we hope that we will carry it forward year after year. I would now like to introduce our speaker for this oration, Dr. Samitra Das. Dr. Samitra Das obtained his PhD degree from the University of Calcutta in 1992, working at the Indian Institute of Chemical Biology. He has then studied the host pathogen interaction in Leishmania. As a postdoctoral fellow, he worked on host virus interactions at the University of California, UCLA, Los Angeles. Later, he served in the same department as an assistant research virologist. During this period, he had discovered a small RNA molecule from Saccharomyces cerevisiae and showed its selective antiviral activity against polio and hepatitis C virus. Dr. Das joined Indian Institute of Science in October 1998, and his research work focused on biology and pathogenesis of several RNA viruses. He has continued to be in Indian Institute of Science, and he's been awarded various awards and research grants. For his research excellence, he's been awarded the National Bioscience Award for Career Development in 2005 from the Department of Biotechnology, the NASI Reliance Platinum Jubilee Award for Innovation and Application-Oriented Research in Biological Sciences in 2010, the Ranbaxy Research Award in the field of medical sciences in 2012, and the Sir J.C. Bose National Fellowship from the Department of Science and Technology in 2014. In the recent pandemic, he has served as the director of the National Institute of Biomedical Genomics, an autonomous institute under DBT. He has successfully coordinated the Pan-India 1000 SARS-CoV RNA Genome Project of DBT Government of India and spearheaded the consortium to understand the functional implications of mutations in the viral genome in the context of COVID-19 disease severity. He was a coordinator of the National Consortium of SARS-CoV-2 genome surveillance and is now co-chair of the Scientific and Clinical Advisory Group to the INSACOG, which tracks the emergence of new viral variants. After completing his tenure at the National Institute of Biomedical Genetics, very recently, he has come back to IISc and is continuing his research involving viral genomics towards disease management. So we welcome you today for this NS Murthy oration.
Thanks for the invitation. It's a great honor, privilege to have this first oration in the memory of Dr. N.S. Murthy, and that too on the birthday of our favorite alumni. And it's good that I could make it today. I would have just missed. I've spent almost 25 years in the next campus. Didn't know so much about Ramaiah and their enthusiasm in research. It's really a pleasure, and I can see there's a lot of promise that I think this Ramaiah can deliver in future. And there is a lot of scope for collaborations with the Institute of Science next door and go together. What we have learned in the last 2 years is that scientists alone can't do it, clinician alone cannot do it. But if you have a pandemic like this, they have to join hands and then go together, and they can really solve wonder. What we have achieved and what we have showed the world that how India can counter this such a disastrous situation with the help of the science and other clinicians. I have a big tribute to all the frontliners, the clinicians who have come forward, and at the time of this crisis, and the scientists who has worked behind it to help them to take the right decisions. So what I have decided that today I'm going to share my experience that I have been associated with the government of India's effort for the genomic surveillance who are tracking and mentioning about the new variants, emergence of new variants, and trying to give you a little bit of highlights about the virus in the beginning. So just in some places it will be a little technical, but I try to make it as general as possible. Please bear with me. So, we have been facing major problem with different RNA viruses, you name it. You have this dengue going on, we have flu, we have now SARS-CoV-2. Now, why it is so notorious is a major question. And the major problem that we face with the RNA viruses is just because of the high mutation rate. And it's just not by design, but it's probably by default. They don't have an important enzyme that really lacks the proofreading activity of the enzyme which actually copies the genome. So the lack of proofreading in the RNA-dependent RNA polymerase and the absence of the exonuclease activity which helps to correct the mistakes, it ends up mutating. And because of the mutations, we ended up with from one species to several quasi-species. But at the same time, the error rate is at the limit of the mutation tolerability. Any organism cannot really tolerate endless mutations. There will be a selection, and that will help them to survive. And the principles that we use for the different drugs like ribavirin and remdesivir is just to cross that threshold so that actually it cannot tolerate, and those mutations and those organisms actually can get rid of it. Now, when there are organisms we talk about, there are mutations. Sorry. There are mutations, and there could be additional mutations, and that we call lineages. And from lineages, we call them sublineages. And when there are some of the signature mutations are replaced by a new set of mutations, and that changes the character of the organism or the virus or the bacteria, then we start calling them as the variant. So we have heard so much. I mean, I keep saying that we have learned so much from the WhatsApp University, which we couldn't even read in any text or in any literature. But so now it's a common knowledge. Everybody talked about the variant of concern, variant of interest. So essentially, not all the variants are of concern, and all the variant of interest. There is always a problem of variant of concerns. All the variant of concerns are mutants, but all mutants are not variant of concern that we have to keep in mind. So if we go by the history, we have watched in 1918 the Spanish flu, which have actually, we almost lost 50 million people. Then we had in 1968 that H3N2 pandemic, which has killed millions of people. And then we have experienced in 2009 the H1N1. So it's nothing new for the human race. And most human coronaviruses, SARS-CoV-2 is a coronaviruses, are usually mild. We have experienced earlier the beta coronaviruses like SARS-CoV, which we now call SARS-CoV-1, and also the Middle East Respiratory Syndrome coronaviruses or MERS, that was little more notorious, which has caused that almost 10,000 cumulative cases in the past 2 decades, with mortality rates of 10% of the SARS-CoV-1 and 37% for the MERS viruses. But what we have experienced in the beginning of the 2020, actually at the end, 31st of December 2019, the WHO China, they have actually, they informed about the new emergence of a new particular strain of coronaviruses. And the Chinese authorities identified this new type of this coronavirus, named it as a novel coronavirus or NCOV, which was isolated first in the January 7, 2020. Now the question was, where from suddenly we just got this virus? Is it from something like a bat or pangolin? There's a big debate. So when we looked about the sequence of the viruses that's isolated from either a human or from the bat and the pangolin, it looks like there are almost 91% conserved. But scientists have looked at it more carefully and they found that there are some actually mutations, particularly in the receptor binding site, which is conserved between the pangolin and the human. And there is also an additional furin cleavage sites which actually makes them more susceptible to human. And that gives an advantage for the SARS-CoV-2 to infect the humans. So what we have learned is essentially there is interspecies transfer of the coronavirus is possible just because of the different mutations in the receptor binding sites. So one hypothesis is maybe the bat coronavirus have somehow infected the pangolins. The pangolins was consumed by the human, and from human by the droplet transmission, it actually passed on from one to others. And there were some sporadic reports that there is a transmission to the tiger and the cats, but fortunately that didn't really sustain much. So we were actually restricted to human, and we found that there are host factors that plays an important role in deciding the productive viral infection. The virus might land up with some system or a host, but they may not be able to replicate or survive within that unless they have the required armory there or the required things that they need to have replications. If you look at the genome, the SARS-CoV-2 have actually, it says, little naive genome. There are non-structural protein and there are structural protein, which is the spike, envelope, matrix, and the nucleocapsid. And this is the envelope protein and the spike protein. All of you know the spike protein because that's the one that has been used for the Covishield and majority of the vaccines. And within the spike also there is a receptor binding domain, which is more important for the vaccine development. But the major problem that we have that the SARS-CoV-2 is a novel coronavirus. It does not have an active adaptive immune response and also known to shut down the interferon secretory pathway and thereby overcoming the innate immune response. As you know, we continuously encounter different pathogens, but we very rarely get infected or get affected because of our innate immunity. But this virus somehow have learned to escape that immunity, and that's how it becomes so notorious and so challenging for us to handle it. Now, what happens like suddenly this virus becomes so notorious? So, you know, as I told you that RNA virus, this is nothing new, that they can keep on mutated by the antigenic shift or antigenic drift. The students, you are aware of it. When there is a small changes, we call it a drift. And when there's a major change or the changes of the genome or exchange of the genomic material, then we call it as a shift. Now, because of the different host, if accidentally the virus ends up with another host, and in that host, it actually, the intermediate host, it gets further mutated, then it can acquire an ability. Let's say it was not supposed to infect humans. It was supposed to infect from bat to pangolin. But because of some undergoing mutations, it has acquired the ability to infect humans, and that too with a much more susceptibility or much more transmissibility. That's precisely happens because now, because of the mutations in the viral protein, which we call ligands, it can now accept different receptors, which we call receptors. Now, when a virus infects a host, we know there is a receptor and the ligand interaction. But if there is a mutation, then it's possible that it can recognize other receptors as well. And that's how it actually gained the advantage of infecting more and more human population. So the mutated ligands might infect the cells upon binding to the accessory receptors. So now I will tell you the story how I got dragged into this whole genomics business. So I was actually heading the National Institute of Biomedical Genomics, and it's actually late 2019 and then early 2020. We started experiencing this Wuhan, and most of these institutes were shut down all over India. But we were not allowed to do that because we were actually asked to sequence the viral RNA and give the nations what is actually happening. So what I did is initially we just sequenced 10 sequences. We had a collaboration with the NICET, the IU hospital in Kolkata, which is a National Institute of Pulmonary Enteric Diseases. They were actually handling the coronavirus cases in Calcutta. So they gave us some 10 samples, said, can you really get the sequence? When we sequenced, we actually found there's something very interesting. There's a mutation which we named it as D614G. And this D614G is actually make this virus very, very susceptible. This is only one pocket in Calcutta at that time. But we reported it immediately, published it, and we also noticed that there is another mutations in the nucleocapsid. Remember, I told you the virus has non-structural protein and structural protein. The structural protein is the spike envelope nucleocapsid at the matrix. And we showed that the mutation in not only the spike, mutation in nucleocapsid can also alter the host susceptibility towards this. We actually did a little bit of structure with the help of our Dr. N. Srinivasan, whom we lost during the COVID time at IISc. So, and he showed that how the mutation can actually alter the structure, three-dimensional structure of the spike protein, so that it is becoming more susceptible and it can be more transmissive. So we did this 10. So when we did this 10 in June and published, the government of India, actually the NITI Aayog and the Deputy Secretary of the NITI, Dr. Swarup, called me and said that can you just really take samples from all over India, different places, and get 1,000 sequences, 1,000 genome sequences from different places. So I was given 5 institutes, 5 DBT institute, and 2 of them are actually instant NCBS from Bangalore, and IBMG in Kalani, NCCS from Pune, CDAP from Hyderabad, and ILS from Bhubaneswar. So what we tried to collect samples from different zones and ask the question, are we seeing any difference in the different parts of India? Because there are reports that some of the states are actually, people are dying. Some of the states, it is not so severe. Some of the states were not even reporting any infection. So what is actually the variants that are circulating in those different zones was a question. And we actually found that the Wuhan strain that we started in March in 2020, we can look at it in April, this is the May, and in the June, this is replaced by the D614G that we have reported in the June, that this is going to come up. That was in a small pocket in Kolkata, but now it started actually hovering around everywhere in different states. But within different zones like the east, west, south, west, and north, you can see the emergence of the variants are also varying. And this is something interesting because we believe that the host determinant is important. It is always important that the virus is yes, not yes, but whether virus will be effective in that particular population is a question of the immunity and the other determinants within the host. And that's essentially too much different in different parts of India, east, west, north, south. That was the study that we have published. So when this was going on, and by the time we reached it 2020, Christmas time. So everybody was very happy because Wuhan was somehow under check, and there was vaccine in place. The healthcare providers were already vaccinated. We see there's a drop, but suddenly there's a news that there are some UK strain has come up, and which is actually killing a lot of people in London. So government of India called a meeting and they said, you have to now extend your network and make it something a national network. And this is probably first time in the history DBT, CSIR, ICMR, Ministry of Health all came forward together and made one small consortium to handle this national surveillance network, which we named it as INSACOG. The aim is to hold genome sequencing data with the clinical and epidemiological data that advances advanced preparedness for the public health and intervention. So the idea is actually we started with 10 hub labs and we made multiple spoke labs. Now at this moment we started with 10, but today we have 57 centers all over India who are actually collecting samples, sequencing them, and actually we're trying to make a sense out of that and finding it out that whether there is a new emergence of the variants which can be actually a big threat to the human health. So that we inform the government. So the workflow is essentially we get samples from different places. We collect the samples, we send them to hub centers or the IGSS integrated genome sequencing laboratories. The sequencing is done and then uploaded into a database. Now we have a national integrated database, IDBC, and also in IBM we also had a data hub. We deposit there. We also share the information with the NCDC, National Center for the Disease Control. And from there, we also actually apprise the government and the ministry. And at the same time, we upload into the National Flu Database, which is called the JISAID. So the sequence information is available around the clock to the international community that India is having this kind of sequences. Are we going to be alarming or not? And at the same time, to understand the biology of the viruses, whether this virus is more notorious or not, we try to isolate the virus in 4 different centers. One is in RCB Faridabad, one is at NID Pune, in ICMR Institute, CCMB Hyderabad, and ILS Bhubaneswar. We try to isolate those viruses and try to see if we culture those viruses, are they really becoming more infectious or not, and whether the pathogenesis is more or not. So with this, actually, I will just show you how we have emerged. So that was the UK strain I told you. Later on, now the nomenclature is changed to alpha, and then come out with the beta, then gamma, then delta. Actually, they originated alpha from UK, beta from South Africa, gamma from Brazil, and delta people say that originated from India, and Omicron, I think, from everywhere, it just all runs. What you need to find out that there are some signature mutations in the alpha, beta, gamma, delta. Some of them are actually retained. Some of them are actually identified for the immunization. Some of them are identified for more transmissibility. Some of them are identified for severity. So when the sequencing is done, what we have to look at it carefully. Are we seeing any signature mutations, which is going to be an alarm? Okay, so that's essentially we keep doing it, and that then sometimes in January 2022 we started getting actually November onwards we started getting Omicron, and when we sequenced Omicron, we found the Omicron has alpha sequence this much, beta sequence get this much, gamma, delta, and westwater. So it collected different sequences from different strains and made it its own sequences as well. And that's why Omicron was so successful in invading the whole population and outplacing the delta. So what we showed, actually this is the constellation we said, that if there is any hotspot mutations are conserved, then the color is purple. And if it is white, that means in some of the strains we do see the mutation, but not all the strains. So we actually watch it whether it becomes from white to purple. The moment it becomes white to purple, then we take it seriously that those mutations we have to really look at it. Maybe virus is getting some advantage having those mutations, and that's how they are saving it in all the sublineages that they are having. So you can see October 2021 and now October 2022, how we have actually moved from Delta to the Omicron. So just from around maybe before January, November onwards, you can see Omicron started and now Delta is almost disappeared. Okay, so that's how the whole thing. And now I call it actually Delta. There was for some time people used to call Delta plus. Now, the Omicron came and Omicron has so many sublineages, I call them as the grandchildren. And if you really look at the grandchildren, there are so many grandchildren, and you can see how they are changing over time. These are all Omicron. But within Omicron, you can see from January 22 to October 2022, you can see the color changes, and these are the Omicron different variants. If you read in the newspaper, BA.2.75 is now the most prevalent variant going around. But there is one more, I'm going to talk about that. And there is BA.2 that is also there. But one thing, as I mentioned, that BA.5, BA.4 was actually havoc in different countries, in European countries, in America, but did not really make a dent in India. Could be two things. One, we have some different genetic data or setup. That's how we are able to counter it. Or the immunity that we have gained because of the vaccines is probably helping us to somehow save ourselves from the BA.4 and .5. But somehow we are still able to allow the BA.2.75 to grow, and then, but it's mostly mined, very few are actually getting it. So this is the picture that we are from the sequences that are uploaded in the database. The green is actually Wuhan. Then from there we get into the delta, and this is the timeline. And you can see the delta is replaced slowly by the Omicron. But Omicron, they have so many grandchildren, they don't have a single color. It's actually a mixed bag of different sublineages or microlineages of Omicron, which are actually going around. And what we have done, we have started from 10 sequence, then maybe 1,000, and today we can probably say we have almost 2.8 lakhs actually. Genome has been sequenced in India, and those sequences of that 2.6 is already uploaded into the GISIC. And we have found that 2.75 Omicron sublineage is the more prevalent at this stage in the country, but there are other strains which are actually coming out. So this is a national network. We keep meeting, we used to keep meeting with the PSA and the NITI Aayog and all these secretaries of different centers, how to sustain this network, because this is first time all the funding agencies, all these government agencies have come together to make a network. So we thought two things is important. We need to continue this surveillance, but the patients are hardly coming to the doctors. So unless they come to the clinics, we have no clue whether they are actually infected, which sequences are actually hovering around. So to look at it, we now included sewage surveillance, which we call wastewater surveillance. Now in wastewater, we have seen that before the sequence showed up, the variant showed up, 15 days prior to that, we can actually detect them in the wastewater. So in the wastewater in different community, if you see that you are getting some virus populated, then you can alarm the healthcare providers that in that place there is a chance of a surge coming on. So this is something which we are working. We also felt, as I told you, that we have learned that the scientists alone cannot do it. It has to be with the clinicians. So we made a huge hospital network. In the hospital network now over 20s. Now I will show you a slide on that. And we are also trying to work on the impact on the immunity, the longitudinal study to understand the long-term post-COVID complications and the changes in the immunity. And definitely we are gaining the knowledge, and more importantly, now we could establish the infrastructure all over India, very remote place. But now they have a capacity of sequencing, interpreting, and making a sense out of that and sharing that information to the government of India to make logistic steps. So this is something which we can proudly say. So the way forward is we are trying to continue the surveillance, expand the genome network to increase the capability in the country, sampling sequences of the hospital patients. And we are also trying to keep on building up the capacity. And more importantly, as one of you mentioned, that it's very important to integrate the data. So the data integration, we are actually trying to harmonize the protocol and the pipelines and develop data sharing and integration. The protocol and pipeline is also important. As you might have heard that some people who are doing bioinformatics, there are different pipelines. The same BA.2.75 in one Pangolin database could be a different nomenclature in others. So lot of times we ended up, every Friday we meet to Singapore, and we are just in a fix whether this has to be taken seriously or not, or it's just because of the pipeline that they have used is something wrong. So we need to harmonize that, and it's important to develop the data sharing and integration. The data has to be shared real time with the outside the country, with the neighboring countries, more importantly. The hospital network is actually coordinated by the THA steer, Dr. Pramod Garg, some of you might know, and also NIBNG is a part of it, where we try to estimate the severity of the COVID-19 among patients infected with SARS-CoV-2, identify the risk factors. If there is a variant coming, do we think that we have to raise the alarm? Do you think there is going to be oxygen shortage again? Do you think again the hospitalization cases or beds will be a scarcity? All these things, or whether it's the impact on the age, comorbid conditions, and other things. We try to link the molecular epidemiology with the clinical outcomes. This is something that's going to help us in the future. This pandemic, we are looking, it appears that we are turning over and we're probably coming out of that. But we have to keep this knowledge in mind that how this epidemiology information can be correlated with the clinical outcomes and identify the occurrence of, if you remember, there was a black fungus suddenly came out. And we try to see whether there is any specific association with a particular variant of the or a particular locality or community or not. Is it a general observation or just because of the immunity was down, or there was some other association things that those are the things are being addressed by the hospital network. And this is the network, mostly Apollo Hospital and some government hospital. The one in orange is actually the hub centers. The one in the blue is all the satellite centers, and the red color is with the Apollo hospitals and the other government hospitals who are actually part of this hospital network, huge hospital network. The wastewater, similarly, as I already mentioned, that we are trying to have the whole genome sequencing and also try to find out three things. Number one is we detect the virus from the wastewater. We try to check the virus load, whether there is any increase in that particular community or not. Then detect the variant by sequencing and try to identify, are we seeing an emergence of a particular variant in that particular community or not. So this is something will be probably in the future. This question I keep getting from the newspapers and also the reporters, and also everywhere I present, that how long this COVID-19 will take to disappear. It's a tough question. As you know, Spanish flu had 3 waves, and Nature has conducted one survey and asked for 100 immunologists, and almost 90% of them responded that they think that we are actually possibly coming into an endemic situation, meaning that it will continue to circulate in a pockets of the global population for years to come. But failure to eradicate the virus does not mean that death, illness, or social isolation will continue on the scale seen so far. The future will depend heavily on the type of immunity the people have acquired because of natural infection or vaccination, and awareness of wearing mask or protecting yourself when you are in the unknown public. And this is something you are going to read in the newspaper every day. There will be a new strain and new recombinant. Now there is something that is bothering us in XBB that has come out in Singapore in heavy rain. But again, in India, we started detecting it, but so far we don't have any correlations with the severity or hospitalization of the cases who are having this XBB, which is actually a combination of 2 Omicron strains, BA.75 and BJ.1. So nothing to worry about, but that also doesn't really allow us to lower our guard. I think we should be still careful when you are in a huge gathering. It's better to protect yourself the way you want, but just to be allowed that we don't really allow one more epidemic to come and grab us. So this is something, the knowledge that we have learned to prepare ourselves for the future pandemic. We believe that it's not in isolation in a country possible. We have to have a global network. We already started talking about the neighboring countries and try to have a global network so that the scientific bodies of different countries continue the surveillance. Knowledge gained and the differential immune response due to host genetic diversity can be extended to other viral pathogens. If you see a particular tribe, if you see a particular community is were protected, can we really learn from there how they were protected from the SARS-CoV-2? Can we use that knowledge for the public health in future for the other pathogen to come, which we don't know? Maybe we have to somehow get some more knowledge from those populations. That we are trying to do it. In some type of national network and infrastructure will allow faster characterization. If there is another epidemic, now we are ready with this 57 laboratories all over India that we can immediately detect by sequencing that what is actually going to happen. And accelerate the development of the next generation sequencing based technology. You know, technology is definitely grabbing. Good that engineer Saab is here. So you know, it's very important that we learn from the engineers as well. I have personally trained a mechanical engineer to do PhD in my lab on mechanobiology of liver. So I believe that this is the time that we have to cross the boundary, and there should not be any boundary of engineering, science, and clinicians. So I think there should be a combined effort to actually keep ourselves prepared for any future pandemic so that we don't get it into a surprise. Now I will get into a little research mode that I have done, a little contribution from my lab at IISc. As you know, that all this alpha, beta, gamma, delta, omicron, they have different kind of transmissibility, different kind of severity, different kind of impact in the population. But when we just first notice that there is a new thing has come, immediate question, are we going to be alert or alarmed to test? How do you test it immediately? Many times, by the time the samples reaches in a laboratory, you can't really isolate the nucleic acid, forget about the virus. So it's very challenging to get the isolation of the virus. So is it possible that we can have alternative ways? So we are actually thinking about sequencing of RNA samples from all India. We are doing that can be continued. But what we are trying in my laboratory is incorporate this mutation in a virus-like particle model. I will show you in the next slide. Or you somehow get the structure of the spike protein by the cryo-electron microscopy and see whether those mutations are changing the antigenicity or the one that we are actually using for vaccines are masked because of the mutations or not. So these are the things that we have to do it. Now, how do you do it in experiment? So we use a model called virus-like particle, which has all the virus structural protein, but lacks the nucleic acid. So it's a non-infectious virus-like particle we generated in our lab. Why it is important? Because this is capable of inducing both humoral and cellular immunity. And VLP presents antigenic epitopes in a proper conformation because you have all the structural protein, not only the spike, you have the nucleocapsid, you have the envelope, you have the matrix. So it looks like a virus that the immune system is looking at. Due to their multimeric nature, adjuvant sometimes is needed, but sometimes it helps to actually make it sustainable. Possible impact of evolving mutations across SARS-CoV-2 structural proteins could be efficiently tested in this system. And so what we try to show here, this is the virus which has the nucleic acids inside, and this is the structural protein which is covering the nucleic acids. But we made an empty capsid where you don't have the nucleic acid inside, but you have only the structural proteins. So what you do is now this can be used to see whether the mutations that has happened, if you incorporate the mutations here, are they altering the entry to the cells? Are they entering, affecting the immunogenicity? Or if you incubate in a cell line, you can see whether it is affecting the pathogens, something like an interleukins, there is a cytokine storm or not. All these things can be measured with this VLP model without the nucleic acid. But the plus is you can do it in your open lab. You don't need an infectious basal-free facility, or you don't need to struggle to isolate the virus. Okay. So how did we achieve this? Is essentially we made a construct which some of you might understand is essentially with 4 promoters. We put it into 4 genes: the capsid, the envelope, the matrix, and the spike protein. And we made sure that all of them are actually expressing. We incorporated the mutations that we found long back in the 10 sequences and see whether that mutations which alter the DLP structure for the pathogenicity or the transmissibility of the virus. And we showed that yes, with these 4 proteins, it actually can make the particle, which we have showed by the electron microscope. We showed the expressions of the viral proteins like the spike protein and the nucleocapsid you can see it. We showed that it can bind to the ACE2 receptor in the F549 cells or in HEK293 expressing ACE2, suggesting that this is acting like a virus. Okay, and we also showed that the viral proteins by Western and showed that the virus particles are actually formed and actually behaving like a virus. Now the question is, will it be immunogenic or not? So we injected into mice and showed that it is actually non-toxic. We had to demonstrate that it actually, there is no change in the mice, none of the mice died, no effect in the weight, no changes, apparent changes in the histopathology of the liver, kidney, and lung, suggesting that this is a safer model. And when we look at the antibody response, we could see that the wild type DLP, either we used the one that is with the Wuhan, or we incorporate the mutations in the D641G or the nucleocapsid mutations, and we try to do it and show that nucleocapsid mutation can also contribute to the immunogenicity. Remember, Covishield don't have the nucleocapsid; it has only the spike protein. So it's important to have the nucleocapsid, and if you have mutations in nucleocapsid, that can alter the efficacy of the spike immunogenicity. So in that case, that is essentially the paper that we published, that it is important to have all the structural protein. And we showed that our actually vaccine candidate that we made by the in the mice can actually live virus neutralization is possible. So now the question is, we also checked the IgG and IgM, showed that there is a progressive increase in the IgM, and so is the IgG, and it is more when you have the nucleocapsid mutations also taken into consideration. So all I'm just trying to say that we can't really neglect the mutations in the. So I'll just try to summarize that we showed this DLP immunization in mice elicits considerable antibody response, both IgG and IgM. Purified DLP have been found to be non-toxic, which is good. We showed the presence of the nucleocapsid mutations actually enhance the IgG response. So in future, when we develop vaccine, this information will be useful, that you keep some of the nucleocapsid mutations in your structure of the immunogen so that that can take care of it. In contrast to Wuhan type DLP, the spike or the spike plus nucleocapsid mutant DLP immunization was also able to induce better T cell response. DLP immunized sera were able to neutralize the live virus, demonstrating the production of efficient neutralizing antibodies against the virus. Obviously, we have patented this from Indian Institute of Science and Department of Biotechnology, and this is published in Microbiology Spectrum, and the media recently covered a couple of weeks back. We were all over in the media to cover that they have made an artificial protein which will be able to combat the mutant COVID-19, which is going to come up given in the future. So where to go? Now we have made the DLP and we showed that there is a model to test the mutant in a cleaner way. Now we extended this study to Wuhan, to Beta, Delta, and Omicron and other variants. We're now trying to have an animal challenge model because some of the studies were actually done in cell culture. We're trying to do a virus challenge model, and we now would like to try different adjuvant. We are actually including one new adjuvant called CGAP, which actually helps to do much more immunogenic, particularly in the T cell response. We're trying to assess and enhance immune response, because there is a talk all over that the current vaccines may not elicit that much of T cell memory response. So there is a scope to increase that, and we are working on it and see whether any of these combination will help us to enhance the T cell response, which will actually avoid keep on having booster every year. So that is something which we are worried about. The thing that I've been talking, I think I had another visit a couple of months back with the invitation of Dr. Nanda Kumar, and we're trying to see now all of us are facing the long COVID problem or a long haul COVID. Now the major problem is that yes, we are getting rid of this epidemic, but some of us who are infected, what we are going to face it in the future is something very important to look at it. And Government of India is also very much interested to fund in this area to see what is the long haul of this COVID. And the one thing that we came in our mind, and actually I'm interested to study the cardiovascular outcomes and the post-genetic determinants and the susceptibility factors. Is that possible that some populations who are infected with this Omicron may not have any severity of the disease, but might have unknowingly damaged something which will probably show up later? I mean, very recently we lost two of our colleagues who never had any cardiac history problems. But later on, if you extrapolate, it looks like it could be a COVID trigger. So we don't know the underlying reasons, and this is something I think there's, your clinicians can help us to understand. We are trying to have the serum biomarkers, comparative transcriptomics, and also the mechanistic approach. We would like to test it in the cell line, whether our hypothesis is true or not. So this is essentially that we did with the COVID, but this is only 2.5 years. But my lab has been working for last 25 years on something else. Actually, it so happened there are a lot of people who are physicists, chemists, who they become virologists. And the virologists who are doing something else become a COVID virologist. So I have also not an exception. We did that. But you have to look back what I have done in the last 25 years. We work with different RNA viruses, which includes hepatitis C, Coxsackie virus B3. This is actually unheard virus, but it causes myocarditis in women and juvenile diabetes in infants. And this is something which is very close cousin of poliovirus. Genome is very similar. I used to work in poliovirus when I was a student, so I extended that expertise into Coxsackie virus B3. But it is also, it causes myocarditis, so it's an important thing to look at it. Dengue virus, as you know, we already have one. Actually, we had a consortium with the RGHS 5 hospitals and IICA 5 faculty. I was one of them. That's how I ended up with the dengue and the SARS-CoV-2 already. So we are actually looking at the biology and the pathogenesis and the vaccines and the antivirals. How do we do that? What I just found over the years that the virus actually gets into the cells. They actually enter through the receptor. It's something like a nice house. And the virus exactly knows how to open the door with the key, enter, and go straight land up into the kitchen, where they get the vessels, the utensils, the reagents to cook good food. And how that is possible is actually in the model of hepatitis C virus we have seen. The virus, hepatitis C, infects hepatocytes, but it doesn't really infect the stellate cells or the Kupffer cells in the liver. Why they are so particular getting into hepatocytes and not the neighboring cells is the question. And part of this is because of these utensils that are there may not be there in the other places. And what the virus does is once they get into the kitchen, they are very clever. They make sure that this make their good food, and this food host can't really enjoy. And it's essentially this food can't be had in one shot, it has to be killed. And that's why it's done by different viral proteases. And those are the ones that are actually done by the viral proteases into structural and non-structural protein. And targeting those, the structural protein, NS5A, NS3, and NS5B are the targets for, there are Suvoscovir, Telaprovir, there are actually drugs on the shelf for the hepatitis C. And some of these are these. And we have seen over the years that it's just like a big orchestra. Virus infects, but it actually somehow hooks or hijacks the host machinery in such a way that these are the protein factors like PTB, LAR, HUR, and these are all actually nuclear factors. They are driven out from the nucleus to the cytoplasm, ask them to bind to the viral RNA into their 5' UTR or the 3' UTR, and then help the virus to make their own protein and replicate their genome. So my all contribution all these years is to identify these players who are actually dancing with the tune of hepatitis C, the PTB, LA, there are several microRNA, HUR protein, and the NS5B is actually the RNA-dependent RNA polymerase, which is the drum, which actually gets this cause. And what did you do knowing that is essentially we targeted and try to make antivirals. We showed that you can target a small RNA which will actually selectively block the ribosome binding to the HCV RNA. And we have got a US patent for that. This small RNA does not inhibit the host cell translation. Main problem of antiviral is the selectivity. And we showed that this small RNA is derived from the virus. It affects only the viral RNA translation, it does not affect the host. And if we are trying to promote that as a antiviral, we showed that some of the peptides, something like a La peptide or NS3 peptide, which are derived from the proteins, the viral protein and the host protein. And these peptides can be used and it can be delivered inside the cells and it can inhibit the viral proliferation. We have actually a collaboration project with Dr. Anjali Karande's lab and Dr. Soma Das. We showed that we have isolated neutralizing antibody from the patient infected with hepatitis C, cloned them and showed that the monoclonal antibodies against them can be a good inhibitor. And we also, this is Dr. Bhan was secretary at the time, we were given the institute, actually Center of Excellence for Hepatitis C virus research in India. I was coordinator for 10 years for that. And we showed that Phyllanthus amoris and pomegranate, these two are actually wonderful. We isolated the pure compound from phyllanthine and corylagine from Phyllanthus amoris and also punicalline and punicalagine from pomegranate and showed that how these natural compounds can actually inhibit the viral proliferation. This is something which Kumar was asking, how we can make it translational. And what the student who went to pick me up in the morning was saying that we're trying to see how this week can actually help people to motivate in translational research. This is actually my thought is we started working on translation because I'm trained in the area of protein synthesis and I made it translational and showed that it is possible to actually achieve that. But nothing is possible with a single laboratory. And this is essentially my hands. It's all these collaborations with different laboratories. We work with the antivirals. We work with the host virus interaction, with the pathogenesis. I have Dr. Shiv Shareen. I was just telling you, Dr. Shalini, that Dr. Shiv Shareen is one of these, like you're talking about NS Murthy, these are the visionary, they're clinicians, but they just encourage research so much. And he has founded for the Institute of Liver and Biliary Science, ILBS in Delhi. Rakesh Agarwal, who is now the director of SGPGI, he's moved to Jigmar now. Ravi Kumar in Yashoda Hospital. We have started working on liver mechanobiology. This is with the engineering. We have a biosystem science engineering department in the institute. And I was from the beginning associated with the BSSC group, where we are encouraging engineering students from different streams to come and then address biology questions. And we are also trying to have a clinician participating in that. So I was actually expecting that some of your students, if they are interested, they're welcome to come. They can actually, there are formal and informal, both ways possible to have an orientation in different laboratories of their research interest. Just to nurture their interest, just to motivate them to come into the research. You know, MCI has made it mandated. That's a compulsion, but I think it should be more will and a motivation rather than a compulsion. I think we'll be always happy to help you. We did talk about the different targeted delivery that also I worked. One of you were mentioning about Dr. Ajay Sood. He's my collaborator and partner in this liver targeted delivery. VLP and DNA vaccine, I already told you, monoclonal and neutralizing antibody. Those are the things. But what I'm just trying to see, it's a single virus. You can see how many ways you can address the virus and solve the biology of that particular virus and try to find out something which will be useful for the human health. And nothing is possible without a laboratory. And this is my current laboratory. It's a very dynamic situation, like the variants in sarcophagus states keep on changing. Every year, some people graduates and the new people join, but the average life size is something like a team. And we work as a team. And I will be happy to collaborate with NSR students, faculty, anybody who is actually interested to join hand and research. I mean, I'm trying to even help with it without my expertise also, just to put you in touch with somebody who will be actually better helpful in a particular area. So just feel free to contact. Kumar has my contact address, so I'll be happy to help, and Indian Institute of Science will be happy to help. As you know, many of you have heard that we are actually trying to have a hospital so that we have more clinical things, and this is the transition period, which is more important to IASC to gain knowledge in clinical research, and it's the right time to have good collaborations with with that, and again, my tribute to Dr. N.S. Murthy and his family are all here, and it's really an honor for me to be here. And as I told you in the beginning, that I would have missed to know so much about MS Ramaiah, so much of enthusiasm with your members at MS Ramaiah. Just keep it up and contribute to science. Thank you.
Thank you, sir, for this amazing first-hand information about the coronavirus and its various variants. So please remain on the dais. I'll now request our dignitaries, Professor Raina, Professor Kalpana, Dr. J.N. Reddy, Dr. Shali Muni. To honor Professor Pavitra Das.
We are honored, sir, not. I know, please, please. I feel embarrassed.
We have Professor Reddy with us.
So he has 90,000 citations. He's from Texas A&M University, one of the senior, this thing like
Very fortunate to have such
luminaries.
Please stay on the dais. Request Professor Murthy's family to join them on the dais for a photograph.
Oh, please come side. Oh, and we get up. Oh,
There comes from the emotion.
what is real?
Now,
Many of you are sort of like waiting for the actual event. So we have been running a little bit 10 minutes late, but we will close the program recognizing those who have received awards at national and state level for their work, following which we will close the program. So I would request the dignitaries to sort of like award, and these are all the people who have presented in national forums of their own specialities like orthopedics, obstetrics, and multiple entries would have been there, and they have been recognized and they have been awarded. And an exhibition of those posters have been put up for the last 3 days in thematic areas. And today is the culmination. So we are recognizing those who have received those awards, and we'll close with the subsequent national. Quickly we will finish because everybody time and Pavlov's reflex of hunger is also there.
we request Professor Raina to please come to give the student awards. Dr. Anshul Bhatia from the Department of Orthopedics. Dr. Aditya Karthikeyan from the Department of ENT and Medicine. Dr. Aditya Karthikeyan from the Department of ENT and General Surgery. Dr. Aishwarya R. Katti from the Department of General Medicine. Dr. Anusha from the Department of Ophthalmology. Dr. Apurva from the Department of Urology. I would now request Professor, thank you, Raina sir. I would now request Professor Kalbara. Dr. Bhartam Harikiran from the Department of Endocrinology.
Can you request Pramila ma'am?
Dr. Chaitanya S.A. from the Department. I was right. Dr. Manjula Receiver from the Department of OBG. On behalf of Dr. Chaitanya. Dr. Charita R. for the Department of Pediatrics. Pediatrics. Dr. Deepti K. from the Department of Pediatrics. Dr. Fatima Shabnam from the Department of Pathology. Dr. Pratik Gupta from the Department of Radio Diagnosis. Thank you, sir. Now request Dr. Shani ma'am to give away the awards. Dr. Lavanya DM from the Department of General Medicine. Dr. Lohit Kumar from the Department of Radio Diagnosis. Dr. Madhurya Shetty, the Department of Pharmacology. Dr. Nainira Kapam Danchan Singh from the Department of Cardiology. The Department of Cardiology. Dr. Palniappan Ramanathan from the Department of Surgical Oncology. Thank you, ma'am. I now request Dr. J. Reddy, sir. Thank you, hand over the award. Dr. Prakriti Ramamurthy from the Department of General Medicine. Dr. Pratap Kumar from the Department of Anatomy. Maybe from Anatomy. Dr. Prerna A from the Department of Policy. Dr. Puneet from the Department of General Medicine. Dr. Rahul Jain from the Department of Emergency Medicine. Dr. Ranjita Hegde from the Department of Plastic Surgery. Dr. Shamini M from the Department of Pharmacology. Shamini. Thank you, sir. Thank you for this. Now I request Dr. Savita Ravinder to come on stage to give away the remaining awards. Dr. Shivani Vora, Department of Emergency Medicine. Sonia Babu, Department of Anatomy. Dr. Tara Press, the Department of Veterinary Medicine. Dr. Vishal Patil from the Department of Orthopedics.
Also, you want to comment here?
Dr. Ziba Anjum from the Department of Oncology. Ms. Teju Varshini from the Department of Physiotherapy. Dr. Sweta P from the Department of Pediatrics. That's we come to the end of the research awards. I now request Dr. Master to give the vote of thanks.
I'll really make it quick. This is indeed an honor to propose the formal vote of thanks on this August occasion, which certainly had emotions, the science, and as Caesar mentioned, Gnanam Vignanam Cha Bhakti Sahitam. Truly, I think we have lived up to the motto of the institution, and which has only happened because of the blessings of Narayana, our chairman, sir. The top management, a short notice today, we had the innovation day, and actually we chose today because of Professor Karbanda sir's 1.5 months back. He had told that today is innovation day, and why don't you think of something? So which was with that intent we had it, and certainly from the subsequent times it would be a single Ramaiah family where the entire campus will celebrate this research day as a single thing. So we thank the entire senior management, and we are happy that Professor J.M. Reddy was able to make it. Yesterday we had a meeting to discuss a lot of things, and we told that look, we are celebrating this, so please make your time, and he is extremely busy. So thanks for sparing your time and joining us, sir. So we have CFO sir, sir, all the heads of department and various deans and other faculty members who have taken their time and come in today. But I would also thank Professor Saumitra Das for accepting this. As he told, it's only for the last 1.5 years we have been interacting, and we as doctors tend to think that clinical research is something and omics and is the other thing across the compound. But I think the compound is being broken to ensure that relationship, and we are sure that the engineering side, the medical side, the dental, we will come and work with you, sir. And last but not the least, my own family of NS Murthy sir's family, Madhu, Shweta, Amma, and all the people who are coming together to make this event a truly momentous is what I would say, and we will continue the research thing. Thanks everyone for this opportunity. We will conclude with the national anthem. Divya?
Request everybody to join us for snacks on the outside. Thank you.
The people whose posters are displayed outside, we like